Hello, hi everybody. Thank you for joining us at Exchanging Ideas 29 Global 5G Evolution. A great welcome to all the speakers around the world from the 5G and its ecosystem industry players. We have fantastic speakers from the universities, research institutes, startups, mobile operators, the vendors, research. So this is fantastic combination of various speakers who will be presenting today. And I'm Kanishwaran Govindasamy, and please take a few seconds to click the subscribe button on our YouTube channel. Global 5G Evolution. We are honored to be named among the world's most influential 5G voice by Analytica. We were included in Analytica's latest report on who's who in 5G in the content creators category, alongside some really talented people doing some great things in the industry. And via the global 5G evolution, we built global 5G community with 5G ecosystem experts around the world, from vendor, telco, mobile network operators, service providers, verticals, research institutes, startups, and universities. And Global 5G Evolution is a platform and community providing millions of engineers and students with informative content to help them innovate in the 5G technology domain. And today's topic, I will be starting with the title of 5G Cloud Gaming Driving Revenue Growth for Service Providers. Now, this is a favorite topic, and this is a presentation that I've taken from the latest report by InCode, an arm in the research study of Ericsson. And it's very much focused into driving revenue growth for the service providers, right? So it can be a mobile service, mobile network operator, or it can be any other service providers, broadband service providers, or even gaming service providers, or even private network wants to offer purely gaming service. And cloud gaming is, although still relatively a new technology, it's gaining its traction among consumers, yet service providers are unsure about the monetization potential. And to help provide clarity, InCode, the strategy consulting arm of Ericsson in North America, have evaluated the market trends of this technology in the region and estimated a potential benefit for the service providers. To estimate the business opportunity for service providers, InCode simulated a 5G network that serves the cloud gamers and mobile broadband subscribers through 3 slices, and each with a specific minimum speed, latency requirements, and traffic contribution in a sample market. And it is found that the service providers can expect a 4% overall service revenue increase by leveraging the estimated charges for enhanced 5G connectivity from the gaming slices alone by the end of the decade. Now, if we look at this cloud gaming expanding the reach of gaming content distribution, big technology firms and gaming ecosystem players have launched cloud gaming services recent years and offering gamers new ways to play. And the market has reacted positively, as 16% of gamers, they have recently used a cloud gaming service. And that's quite a good, interesting news. And analysts anticipated that cloud gaming growth will continue expanding the reach to new audience, including the gamers who want to play anywhere and do not want to buy high-end devices and expensive video games. Through the last 10 years, you can see from retail GameStop or a legacy console and PC, it's driving more towards the cloud gaming services. NVIDIA, GeForce is quite popular. Google is taking place, Microsoft as well. Google Stadia is taking place as well. So a lot more cloud gaming subscriptions are taking place nowadays. This is a cloud gaming subscriber forecast purely for North America in 2022 and 2031. Despite being a relatively new technology, cloud gaming is expected to reach 15 million subscribers in North America by the end of 2022. and it is anticipated 99 million subscriptions over the next decade. So the five key drivers for CSPs should consider. Number one is just purely focus on mobile gaming. Number two is attractive gaming subscriptions. Number three, there will be a shift in the gamers' preferences. Number four, there's a major in a cloud service ecosystem. And number five is the rapid adoption of 5G. So because of the low latency and high speed, that will encourage more gamers to come and start to subscription the 5G for cloud gaming. This is the evaluating of 5G capacity and economics with slices. Among of all the industries, I would say that the gaming has actually started with the network slicing. I think network slicing is more appropriate for gamers because of the guaranteed speed and low latency, and also the variable speed and best efforts as well. And we can say that uh, the favorite question for service provider is how to monetize their 5G investment by delivering a superior experiences. And to answer is the ability to enable the multiple differentiated services that can generate new revenue by leveraging the applications. And that's where the new slices we can apply for the specific gaming for the different applications as well. Now, if we look at the target cloud gamers segment adoption requirements, where we can see Incode has estimated that cloud gamers currently make up approximately about 4% of the 5G subscription base, but will reach 25% over the next decade, right? And if we look at in terms of the forecast in 2022 and 2031, there's a split between the advanced performance gamer compared to the moderate performance gamer, and we can see there's a huge growth estimated in 2031 for minimum guaranteed speed, right? So and we can see there's an uptrend where with the 5G basic subscription fee of USD 44, you can see an uptake additional revenue which can be charged between USD 10 to 15 for purely for cloud gaming, based from the slices that has been that can be offered to the customers. Now, if we look over the next decade, service providers should consider incremental price for advanced 5G services. For reference, subscription-based platform have doubled their prices every 7 years, which is equivalent to a 10% annual increase. And this is great news to see based on the growth of the subscriber adoption that is being forecasted to 2031. Now, this is the Incode simulation estimates the service provider can anticipate, as I mentioned earlier, a 4% overall service revenue increase by the end of the decade for the gaming. If this is successful, I can assure you that more other industries can start to able to adopt the network slicing as well. Now, if we look, this is not something new, as I mentioned earlier. On top of the 5G basic subscription fee, we can always see there's an enhanced connectivity revenue uplift for the cloud gaming based on the additional as a monthly additional fee. And there's two things that I would like to mention here. Based from the Incode simulation, found that number one is the model capacity growth plan of the 5G network supports the traffic contribution of both gaming slices and the mobile broadband slice as well, without further capacity expansion and investments. And number two, there's a 4% service revenue increase by end of the decade by leveraging this enhanced 5G connectivity from the gaming slices. And lastly, this is something I would like to stress out, is that cloud gaming will be one of the first consumer use cases to capitalize on the low latencies and high speeds of 5G networks, driving revenue uplift to traditional service revenues. And service providers can extend this technical framework of network slicing and digital enablement to deliver more differentiated services for both consumer and enterprise. And as you know, fixed wireless access, another more popular trend is coming in connected cars, IoT, enterprise, and we can apply the same model as what we have offered in the cloud gaming. So basically, this is overall of my presentation, and I would like to pass on to the next speaker. Let me introduce Ahmad Nabawi from Abu Dhabi, UAE, to present on the 5G RAN and new features. Over to you, Ahmad.
Thank you, Ganesh. Thank you so much. My slides are visible now?
Yes, it's good now.
Thank you, Kanish, for giving me the opportunity to be a speaker today. Here is Ahmed Nawawi. Currently, I'm a technical account manager at Ookla. Previously, I was a solution architect lead at Ericsson Dubai as well. So here, just need to speak about the 5G RAN overview and the new features, as you spoke earlier about the cloud gaming and the new advantages of the 5G, like the IoT and the FWA. All of this based on the 5G rollout or the 5G network. So I would like to take the chance to talk about the 5G legacy and how the 5G started. So the 5G started actually, we classified it in three categories. First, in the service providers and the consumers, and last in the industry. From the service providers point of view, they need to improve their efficiency and profitability, for sure, with the high security, and also they need to improve the user experience by deliver the loyalty to their brand and improve the user experience by giving them high speed, more capacity, and also achieve their targets, as you spoke earlier about the gaming and the streaming, and also getting good offers with the higher data rate. So those all the service provider are seeking for. Also, from the strategic point of view, if you have a 5G earlier, this is advantage in the marketplace as well. In some countries, if you have the first 5G network in your country, for sure, this is getting a strategic advantage in the marketplace. So this is from the service provider point of view. From the consumers or the end users, so they are seeking for the better experience and improve their speed, latency used for the 4K and 8K and VRs. This is the new services need more speed and need low latency. Also, the new experience by the drone and the smart homes. This also based on the 5G network, it is improved a lot. From industry point of view, the industry point of view, it is reducing the OpEx by it's not only rely on the legacy networks by putting a lot of hardwares and doing the normal operations for running the network, but right now also they are seeking for the not having cables for the connectivities to monitor the legacy network. In parallel, the industry is also will commence driven by the cloud automation, the machine learning, and AIs, and also the other technologies to improve their network rollout, reducing the OpEx, and also increasing the operation flexibility. By the end, using the latest available technologies by the industries, this can build also perception of the innovation and the technologies, and can improve their workflow and the working strategy, improving the employees' capability and the employees' experience by getting like new learning about the machine learning and the AI, and also embedded these new technologies in the hardware itself. So those are the main drivers for the 5G. From brand perspective, we just classify or segment the use cases for the 5G in three main categories: the enhanced mobile broadband and the fixed wireless access, and also the cellular IoT. So for the enhanced mobile broadband, this is the first use case in the 5G, as we spoke earlier. The enhanced broadband about the end user. They need a higher speed, they need more capacity because the growth in the mobile traffic need higher data rates. Also, we need to utilize the spectrums to improve the user experience by giving more bandwidth. It will be useful for the streaming and gaming and also the downlink speed. If we are talking about the cellular IoT, mainly, this we can call it like industry digitalization, because in cellular IoT, there are too many use cases under the cellular IoT. Like, for example, the smart meters, electricity and water now can be measured by the IoT's deployment. Smart agriculture as well, it can be done by the cellular IoT. So based on that, we have to have like a good 5G network, good 5G coverage to just support those kind of new use cases. The fixed wireless access, and I'll call FWA, this one can provide the connectivity to the household, or you can say it for the small, medium enterprise using the wireless technology. Also, it can provide the connectivity to the unserved areas instead of adding like fiber cables, which is costly. So we can just introduce or deploy the fixed wireless access technology or the technique as one of the 5G used cases to provide high-speed internet and connectivity to those unserved area. And also based on the FWA, also you can add some value-added services like IPTV, or you can add like the phone calls on top of that by make like differentiated the quality of service for each service and differentiated QCIs as well for each service can be provided by the FWA. This is the main three segments from brand point of view. Next, here, if we go earlier for the legacy network and how we can deploy the 5G, we have two different type of deployments. First, non-SA, non-standalone 5G, and SA, standalone. So those two cores architecture are also standardized by the 3GPP. Here on the left side, you can find the 5G EPC evolved packet core. Option one means this is the LTE legacy, means the same core, the same MME can connect to the LTE, which is the legacy MME, the EPC, which we have right now in the most of the countries. Based on the 5G or based on the 4G architecture and 4G core, the 5G non-standalone it come to the picture by just make upgrade, software upgrade to the evolved packet core. And we are using the option 3X, mean that you have a user plane and control plane coming through the LTE, and user plane will go to the 5G itself, meaning that the 5G doesn't have a specific core. So the 5G deployment, it depends on the 4G core as of now. So about the connectivity itself and the mobility, we are saying the LTE leg should have the user plane, and the 5G leg should have the LTE leg should have the control plane, and the 5G leg should have the user plane to getting higher data rate and more bandwidth. On the right side here, if you see, this is 5GC, means the 5G core itself. It is totally individual and independent than the 4G one. You can say that it is new architecture on the new network completely. We have to deploy the 5G core as based on the option 2, which is standardized by the 3GPP as well. We can implement or deploy our NRSA. It started to be launched in many countries starting from the 2020, the second half, H2. And using some features or some core and RAN features, we can make the internetworking or mobility between the standalone and non-standalone network. The main differences between the standalone and non-standalone one, here, as I spoke, the non-standalone need LTE anchoring. LTE anchoring means that the control plane will be on the LTE leg, the RRC and RETCH should be on the LTE leg, and then we have to add the second leg by adding second RETCH, which is 5G RETCH, to the NR node itself. Then the UE or the user can get 5G services. And here the standalone, we need 5G NR, 5G new radio, and 5G core as well. We have totally separated 5G and NR baseband, totally separated than the LTE one. Based on that, the standalone, a lot of use cases which is not used right now, it will be fully used by standalone for all applications, or any use case need like very low latency, like remote surgery, for example, or 3D hologram calling, some industrial robotics. And all these use cases can be used efficiently after the standalone deployment. After that, 5G as a technology, looks like it's same like other technology like 4G and 3G. It have like hundreds of features, and all of these features just targeting to improve like the user experience itself. But here the main features and the features which make the 5G is unique and is the dynamic spectrum sharing, carrier aggregation, and the 5G radios, which can be used also for massive MIMO. Dynamic spectrum sharing, if you don't have a 5G, and in some countries related, which doesn't have enough how to say enough budget to deploy 5G totally, can utilize the LTE bandwidth by the spectrum sharing feature to make it dual band, dual technology, LTE and NR. Here is carrier aggregation, which lead to improve the user experience and increase the user throughput by make aggregation with the low band and mid band and also non-SA and SA. And the tight interworking, meaning the mobility between the non-standalone and standalone 5G deployment.
Amit, the time is 10 minutes, so would you mind to quickly wrap up?
Okay, خلاص finish. Here the network slicing will be discussed later by our experts, and just last thing is based on the crowdsourcing data, we can analyze the coverage and the new deployment and the new use cases by using this crowdsourcing data comes from like Server or Cloud or whatever. Yeah, thank you, and sorry for taking too much time.
Great presentation. Thank you, Amit. I appreciate that. Yes, moving on to the next speaker, let me introduce Umair Qayyum from Palo Alto, California, USA, to present on the 5G for rural broadband. Over to you.
All right, thank you. Can you guys see my slides?
Yes, sir.
Okay, great. So great presentation, Ahmed, and thank you so much, Kaneshwaran, for the invite. I'm really excited to be here, and I will try to finish this in 7 or 8 minutes, so we have enough time for the next presenter. So my name is Umair Qayyum. I am the co-founder and CTO of Yfrost. We are a early stage startup with a big mission. So we are a 5G for rural broadband company. We have really focused on a very specific niche and a very specific chunk of the spectrum, which is unlicensed for 5G. And we are sort of one of the only companies at this time that are focusing on building the product that we have built. I'll kind of go into a bit more detail in terms of classification or where we fall in the ecosystem for sort of all of my telco friends. We are essentially a vendor. We develop hardware, software, and then services on top of our products that we offer to our customers. So maybe just a quick background on who I am and just how all of that sort of relates. Okay, so yeah, started engineering from Pakistan, grew up there, went to the US to play some tennis and sort of finished my education, worked at Sprint. So that's kind of roots of my telco background from an RF engineering standpoint, and ended up going back to Pakistan and started or actually joined as the second employee for a telecom services company called Ternotech. And that company now is one of the largest service providers in Pakistan in terms of services. From there, I actually came back to the US about 12, 13 years ago, finished my MBA, and did a quick stint at McAfee in marketing, and wasn't the thing for me. Then ended up joining LCC, and that's where I worked on very interesting projects with AT&T, Ericsson, Samsung, and then finally did a lot of work at Microsoft Research, where the roots of sort of how I ended up doing what I'm doing now were set up at Microsoft Research in the Redmond campus. That job led to me joining Adaptrum, which is another exciting startup based out of San Jose in California, where we were focused on developing a product focused on unlicensed TV spectrum. And as sort of happens in most cases of entrepreneurs, that journey kind of led me to founding. So who are we and what do we do? So 5G for rural broadband, like I mentioned, we have a big mission to try to connect the next billion people to the internet. And our focus is unlicensed spectrum and automation, simplifying 5G deployment for fixed wireless access use cases. So that's the focus. That's how we have built the company. That's how we have started. Rural broadband now is big business, especially in the US, but also globally because of many factors, but because the home internet access as the COVID as COVID really showed us in terms of connectivity need and importance is very, very vital for everyday life going forward. So the US government and various programs are now totaling up to $100 billion or over that funding over the next 10 years. And then it's not just the US problem, it's a global problem. So just in the US, there's about 70 million or more people who do not have broadband experience. So broadband is defined in the US, at least at this point, as 25 megabits per second experience of downlink speed. And globally, about 2.9 billion people do not have home internet access. People might have mobile phone access where they can at least use internet, but that does not equate to home internet access. And then global fixed wireless access market, so the FWA market that Ahmed alluded to is, again, it's a huge opportunity for us, and that's the market that we're getting into. The spectrum, what's our secret sauce? What have we solved? What do we as Y-Cross as one of the co-founders think the value? The value is the spectrum. So TV, analog TV has been digitized for the last 15 years or so, and various regulators have over time put regulations in place where this spectrum is essentially treated as shared spectrum or unlicensed spectrum, similar to how we think of Wi-Fi spectrum, or how in the US you think of CBRS, which is citizen broadband radio spectrum, and then some of the other countries in the world also setting aside shared spectrum for private network use cases. So TV white space spectrum falls in the same category. I call it the golden spectrum because similar spectrum in the US has fetched up to insane amount of money for telcos. And we want to build technology to capitalize on the value of this spectrum. So TV white space spectrum, just as an overview of all of us, I mean, it's UHF spectrum or TV broadcast spectrum is very standardized, homogenized. So globally, you can go anywhere. You lower UHF or TV white spaces, as we call them, which are empty or unused chunks of TV or unused channels within the overall TV spectrum that are allowed by the FCC and Ofcom and a lot of the regulatory bodies to be used as unlicensed or lightly licensed bands. And it's globally, it's from 470 megahertz all the way to 698 in some markets, and US, UK, it's 614, but it's, so regardless of how you divide it up, it's at least 150 megahertz to 250 megahertz of spectrum, not just US, UK, Canada, but also globally in a lot of other markets. So there's about 30 or so countries where the regulations are in place, where the spectrum is ripe for disruption. And we have made the first and only sort of product, which is using standard initially LTE technology and then 5G technology to make use of this. So fixed wireless access. Again, I think Ahmed kind of helped me out with his explanation, and I think we all know what is fixed wireless. In terms of when we think about population density or continuum of how people live or are placed in geographically, for the very sparsely populated, satellite is the best or the most economical or the obvious option. That's the bulk of the market of what Starlink is going to be doing or is doing. That's where Viasat, Intelsat, Amazon Kuiper, these kinds of projects fall into place. The other end is fiber or millimeter waves, which is required density to make the business case work, because laying fiber per mile in the US and developed markets is about $5,000 per mile of laying down fiber. And that doesn't add to any sort of good business case in the middle, in the empty spots. And that's where fixed wireless access falls. And within fixed wireless, there is obviously a licensed guys. So Verizon, T-Mobile in the US are making huge inroads, and then operators around the world also have big fixed wireless access deployments. But that's where we, as Whitecross, with our television white spaces or TV white space product, fall in. Just an overview of sort of how we think about our product or the value. Physics of the spectrum, sub-gigahertz is you don't need line of sight. You can put a transmitter up and not have to worry about trees or houses in the middle because of the physics of the radio waves here. And that's sort of what this diagram is denoting. We develop base stations, which go on the tower. We develop this fixed CPE or fixed client devices, which are outdoor or indoor for our customers. And then we have really worked hard on automation. So from unboxing our product to actually deploying, it's about a 15-minute process. And that's the focus. That's the simplification that we want to bring, because if we want to deploy in rural America or one of the rural places around the world, automation and ease of installation, plug and play experience is key. Our current product, which has been in the market since last summer with our early customers, is doing about 100 megabits per second throughput to the end customers and providing up to 5 miles of 8 kilometers of non-line of sight range. And the next generation product that we are working on and shooting towards is going to be a gigabit per second throughput product. Just a high-level overview of some of the markets where the regulations are already in place, and some of these markets are our customers, and we have active files going on or active discussions going on in a lot of these markets where the regulations are already in place. Some of the market segments are here. I think obviously rural broadband is an important piece of it, but I think precision agriculture, IoT use cases, industrial IoT, so remote applications of connectivity are a huge driver for what we are doing, because our customers have these types of companies who are focused on precision agriculture connectivity are already using various unlicensed or licensed technologies, but due to the benefits of physics of what we are doing in the TV white space spectrum and the sub-gigahertz spectrum, there are huge use cases that we enable, not just for precision ag or oil and gas, but also some of the other harder to reach use cases, as in mining or some of the other areas. So
the 10 minutes is so. Do you wrap up quickly?
Yeah, I think so. I mean, I have a couple more slides, but I think I kind of covered what I wanted to cover, and some of the other use cases are in some of the other slides. But I really appreciate again the opportunity to present here, and hopefully you guys learned a thing or two here. Thank you so much.
That was a brilliant presentation. Thank you so much, Umair. I really appreciate that. Now moving on to the next speaker, let me introduce Mikhail Ukrepek from Bratislava, Slovakia, to present on the 3D live digital twins.
Hello everyone. Can you see me? Can you hear me?
Yes, I can hear you.
Great. I'm starting the screen sharing. Share. I'm not going to present you typical presentation, but I'm going to show you how the 3D live digital twin looks like. Can you see it?
Yes, sir.
Thank you. What you see here is the Earth, and that's a good reason. Most of the companies our digital twin are using are global companies, so they need to know where exactly the position of their premise or facility is, including the sun position. So now we see that the light is coming also to the US. Here on the left side, you can see a few tenants we have. So I will start with the Virtual Corporation. Here we have some temporary data I can show you. So here we have 4 plants. One is in Casinetta in Italy, Clyde in the US. You can see here they have early morning. Poprad, that's in Slovakia, here 350 kilometers away from Bratislava. For Radomsko in Poland, it's approximately 600 kilometers. I want to see the Polish plant, please. Okay, and you see here now the logistics live. So as you can see, this guy, number 76, is operating right now here in the plant. And this guy, number 6, is going away, and the guy, number 76, is going inside this tiny hall. So this is how the logistics manager, in this case, the logistics manager sees how the plant operates. I want to see the plant in Poprad, so this is a solution for their central team, so they can compare how all these plants are performing. Great is that in this plant, we don't have just the logistics, but also the production data. So now I'll turn off the logistics. Please show me the production. Here we have different production lines. I see how the production is performing, and you see here how it ran. You can see here that because we have now here 10:30 in the morning, so here you can see that the production wasn't running because they have a lunch, because the morning shift they started at 6 in the morning. If I want to see something else, let's see. Okay, here we can see the performance of the production. So they had a night shift, everything perfect. Then the drop because early morning shift they're changing, and again the performance is going up. So this is typical manufacturing use case. Now let's move to Skoda. Here we have also some examples how the digital twin can look like. So this is the plant in Mladá Boleslav, 2.5 million square meters. Here we have different buildings, different routes, different, let's call it pipes or wires, or it can be anything. You can see drinking water, heat, compressed air, electricity, so we can visualize any kind of data source. Please show me how the building looks like inside. Okay, and here you can see how it looks like. We support multiple floor buildings. So, and again, here you see the logistics. Please show me the spaghetti chart. I like spaghetti. And when I switch to the transparent mode, you can play this guy's shift like a movie. You can start with the play button. You just move the zoom window to the other monitor. Okay. And here you can switch to a high speed. So you see how the time is running. Okay, he was here at 6:05, at 6:10, he was again back. So this is how his shift looked like today morning. Okay, but we don't have just the logistics. So now I switch back to the material view. I want to see, for example, the temperatures, because they have different sensors for the heating. Because we are in Europe, we also need heating in some seasons. Water leakage I will show you at the end. Here we have the bins. So they have, just in this one building, more than 150 different kinds of bins, and they need to know this is for mixed. Show me this one. This is for plastic. This is for scrap, as I see, or here, iron, metal, and they collect it on demand, for example. So they need, for passportization, to know when they have to empty the bin. Here we have the data about the machines, so we can check how the production is performing, if it works as expected or not. Every single parameter you see here is a threshold, below and above, in between. So when you reach the threshold, you get a notification. If you want to play with the app, just go to your app store. Doesn't matter if iOS or Android. Download the app Twinzo Digital Twin, and you can play with the showcase demo zone. There is an office, an hospital, whatever. So here you see different zones where when we check then the logistics, we can show or tell who spent how much time where and when. Here we see logistic gates. For heating, it's important. That's why this open one is red, because open gate, especially in winter, means that you are losing the heat. It increases the heating and you are wasting money. Not not the money from the window, but from the gate. And in this case, you can see here the visualization of the heating system, because guess what? You have in your plane heating system, but it has no visualization. So it tells you that you have an issue in one of the pipes, but you have no idea which pipe it is. So you need something like that. So you know that the X-host number 1920 is this one, and 19 or 31 is this one, or this pipe it is. Okay, let's move to the water leakage module. So, okay, because water is sometimes too strong medium. Voila. Okay, and here you can see the drone scan showing you where are you losing the heat. So you can say, okay, these yellow places, so that was handwritten in the system. Okay, these yellow places are risky. The green ones are places where they fixed it on the roof. And blue ones are places where they have found the water on the ground or on the shop floor. Then they can begin to think where the water is coming in and when they found it on the ground, because of course it's another place. Okay, and the last thing I'm going to show you is a smart city use case. It's a pilot, so here we don't see even not historical data, but it's just a demo. So it's very good for just getting the idea. So companies providing different kinds of 3D models. In this case, the drone scan. They have this kind of models, but they don't know how to bring it to the life. So there is on some sample data about the bridge condition, where are the vessels, the condition of the chamber or the lock, or who are the tenants in the neighborhood. So companies, they are having the premise there, or in this case noise level, but they don't know how to glue these things together. And this is exactly the topic where 5G connected to a digital twin comes into the game, because you can get the data through different sensors, send the data via 5G technologies, and glue everything together under one roof. That's it. Thank you.
Michelle, this is fantastic. A great stuff that you have. I think it's one of the best digital twins that I have ever seen. And perhaps, maybe another session I need to have with you to see what else you have. Thank you so much. I appreciate that, Mika. So moving on to the next
Thank you very
speaker.
much for the invitation. All the best.
Yes, sir. Let me introduce Charu Paliwal from New Delhi, India, to present on the topic of 5G private network. Over to you, Charu.
Sure, thanks. Thanks, Ganesh, for extending the invite. I'll just share my screen. I hope my screen is visible now.
Yes.
All right, I'm excited to be part of this 5G conference. Hello, everyone. A brief introduction about me. I am Charu Paliwal and I work with Counterpoint Technology Research as a research analyst. I look into 5G networks, operator strategies, private networks, and topics like network infrastructure and more. And today I will be talking about one of the most talked about or the hottest topic in the industry, which is private networks. So we have seen a growing number of private networks deployments in the market, and there are more and more markets opening up to private networks. And there are factors such as real-time networking and time-sensitive networking that have played an important role in driving the growth of a global private network market. Private network supports a variety of use cases. Now, these could be your primary use case, such as providing connectivity to locations not covered by public wireless infrastructure, or there could be industrial IoT or mission critical applications that require extreme high resilience, high bandwidth, and specialized capabilities such as ultra low latency or time sensitive networking. Now, looking at the market overview, we have seen US conducted CBRS spectrum auction way back in 2020, wherein more than 228 bidders won licenses and raised a total of $4.5 billion. We see Germany at the forefront of private network license allocation. There are more than 200 applications that are granted in the region. Then we recently also heard China, which is also indicating that there are thousands of private networks being deployed in the region. Then there is a vast selection of hardware vendors that offer private network solutions. These hardware vendors not only offer your basic network equipment, but they also offer full range of private network solutions based on LTE or 5G technologies. We see the private network space is predominantly led by established vendors such as Nokia, Ericsson, and Huawei, and as they offer end-to-end solutions in association with their partners. Overall, there are significant growth opportunities for vendors and other players in the ecosystem to develop new products and solutions. Moving on. So now we will talk about key market drivers and key trends that we have seen in the market. Now, key market drivers behind the growth of private networks can be identified as availability of licensed and unlicensed spectrum and emergence of industrial and commercial IoT applications. Availability of unlicensed as well as licensed spectrum bands paves the way for enterprises to directly deploy private networks quickly and without the intervention of MNOs. It is encouraging to see a growing number of regulatory bodies have opened up the markets, and they're bringing in policies and legislations to make spectrum assets available to enterprises. Latest example being India, where the government recently announced the direct allocation of private network to enterprises. Then there is increased application and technological development, I can say, in industrial and commercial IoT scenario, or robotics, or machine learning, and even public safety segment and more, that are generating interest from enterprise perspective. And these factors are also expected to shape the future of private networks. Looking at the key trends that are seen in the market, they would include your big, large industrial groups and large enterprises. We think they are more likely to acquire their own spectrum rather than relying on traditional MNOs. LTE private network deployments, we have seen more and more higher number of LTE private network deployments compared to 5G. And we expect this trend to continue in the coming years, especially given the established ecosystem when it comes to LTE. Then there are large vendors that are increasingly expanding their ecosystem. They are increasing the number of partnerships with the other ecosystem players. Now, this is mainly to cater to the enterprise segment directly, or engaging with the enterprises directly and bypassing the MNOs. Lastly, which is an interesting trend that we have seen, is the growing number of players that are entering the market. And these new entrants including your hyperscalers. They are coming up with easy and simplified solutions, which in a way will definitely help in creating market awareness, and they are likely to target the low end of the market. Continuing with the hyperscalers and the new entrant topic, I would also like to touch upon how these new entrants and evolving ecosystem is shaping up private networks market. So the market is evolving with operators, your system integrators or equipment vendors, and then there are specialized solution providers that are all working together to meet the enterprise needs. We have seen CBRS operators entering the market. Then there are specialized service providers entering the market. In some cases, we will see operators will lead the deployment, whereas in others, we will see an ecosystem player with an established partner ecosystem will lead the deployment. However, the main important thing here is the collaboration between all these players. It will be an essential part to grow in this private networks market over the time. Although it is still an emerging market and many players are offering vertical specific solutions or vertical specialized services, including your hyperscalers. Hyperscalers are also bringing in innovative and service-based models that resonate with your enterprise requirements, and hyperscalers have also the power to disrupt the private network market. Now, why do we say that? So, because hyperscalers are helping in automate the setup similar to Wi-Fi in terms of simplicity. They're trying to capture Wi-Fi market, or maybe more than that, by bringing in reliable, easy, and quick to deploy solutions. And moreover, enterprise can also control the entire private network solution setup on a single dashboard. So ease of deployment plays an important factor when when these players go and talk to enterprises or to bring an enterprise on board, considering the private network market. So in a way, hyperscalers are basically simplifying the solution, and we see AWS as a player is well placed to do that. So although there are more and more players entering the market, but this does not imply there is no opportunity for other players or the traditional players, because it is the private network market is touted as it can grow into an opportunity which is even bigger than Wi-Fi market that exists today. The need of the hour would be the other traditional MNOs and other vendors. They need to up their game to stay relevant in the industry, especially considering the hyper competitive scenario after the entry of players like AWS. Lastly, I would like to touch upon certain challenges that we see in private network space. There are challenges such as device availability, delayed release of standards, and more. Device availability, I'll say it still remains a challenge even today, because there are a lot of features and specifications that are not even defined yet. You need 12 to 18 months for specifications to be finalized and devices being made available in the market. Some players that are willing to enter the market, they still feel that private network market will take another 2 to 3 years for the device specification and chip availability to develop up to an optimum level. Then at the same time, there are also some macro environmental challenges that could range from your chipset availability or chip shortage due to the pandemic. Then there is rising geopolitical tensions. And most recently, the ongoing war between Ukraine and Russia have also added to the woes of this entire tension globally. So therefore, such factors do hamper the production of device and network equipment. Plus, at the same time, 5G device ecosystem, especially in view of industrial environment, is still not fully developed. So overall, these factors collectively affect the entire ecosystem, and they are also expected to affect the pace of 5G private network rollouts, at least in next 1 to 2 years as well. This brings to the end of my presentation. Thank you so much.
Great explanation, Sharu. Thank you so much. I would fully agree with you when it comes to the challenges of the deployment of 5G private network. A lot of the 5G private network operators or service that I've into often say the same situation. So hopefully, something really good. The government should encourage more support as well. So thank you, Charu. Appreciate it. Let's move on to the next speaker. I would like to introduce Dr. Lina Maria from Abu Dhabi, UAE, to present on the key trends of digital twins empowered by 6G. Over to you, Dr. Lina.
Thank you, Kanash. Thank you for invitation, and thank you all for being here. It's really nice to discuss these topics with you. Can you see my slides now?
Yes.
All right, so I'm Lina Beria, a senior researcher from the Technology Innovation Institute. And recently I started exploring this digital twin concept and how it can be applied to 6G networks or future wireless networks, as we still don't know what 6G networks, and with emphasis on smart cities applications. Now, smart cities, or the concept of smart city, is not a new topic. It has started early 90s and it has evolved over the last, let's say, 30 years. And basically it started not the way that we envision smart cities now. It started with basically having wireless connectivities, having some base stations, some wireless communication, like the very basic one. And this concept has evolved over these years, motivated by many factors. First, like we expect by the 2030 to have more than 60 to 70% of the world population living in cities. And this means more energy consumption, more traffic, more pollution, more waste, and managing all these things require much more than what smart city concept offers now. And this has motivated as well the research in 6G networks and how 6G networks or future wireless generations will contribute to the development of this smart city concept. Now, what we envision from, although it has developed a lot, but what really our vision for a smart city is to have every node, everything connected and everything intelligent. So to have kind of pervasive intelligence where artificial intelligence can contribute to each node in the network. So we'll have smart environments, smart traffic, smart mobility, smart logistics. So traffic lights will not be only for like traffic lights, they will have different functionalities. Building facades, your house windows, not only for nice views, they will be your gate to be connected to the outdoor to provide better performance. So the lighting system in the streets, everything will contribute to this intelligence. And then we expect to have like an intelligent city, and then we can call it really the smart city vision that we are looking for. And this is motivated by different trends. Like first, we have the concept of big data. Now we have a lot of intelligent applications that generate a lot of data. We have the number of mobile users, the emergence of Internet of Things, Internet of Everything paradigm now we call it, like generates a huge amount of data that can be really utilized in order to provide better services for city people. As well for the sensing, because basically with sensing or with pervasive sensing, we can get that amount of data with the different applications that we have for sensing, including VR, AR, and the digital twin and future, all motivated the concept of smart cities and smart city applications. And lastly, distributed intelligence, as I mentioned, that it will not be any more the base station that will do everything. each node in the city, each node in the network will contribute somehow to this wireless communication, to this intelligence in the city. So the concept of distributed intelligence as well motivated or was a key driver behind this smart city applications or smart city concept. So I will go over generally over some technologies that will as well motivate the need for digital twin in smart cities. And it's not only because we want to have more into this virtualized services or to match this acceleration and virtualized networks, but several wireless technologies has recently emerged as like enablers for wireless communications and that are necessary for, let's have, realizing this smart city concept. And one of them is the reconfigurable intelligent surfaces or large intelligent surfaces, which are intelligent surfaces with unique properties that can be tuned in order to perform particular functionality. So we can modify the phase and the phase and the amplitude of each element in this intelligent surface, which consists of many metasurface units, and then depends on the functionality or your target, you can tune these parameters of these elements in order to perform, for example, extended coverage, to perform enhanced security, to have more, or to support multi-user. So it depends on your scenario, you can tune it. This has been now studied in many literature as a really enabling technology for smart cities because you can utilize the building facades or any like large area where you can cover it with these thin meta surfaces or thin intelligent surfaces, and then you can increase the coverage, minimize the interference, support much larger number of users within this surface. And there is even more advancement in these surfaces, which is offered by Docoma in Japan, where they provided a transparent one. So basically you can place it in a window at like all buildings, and then you can provide better communication for the people outside the building as well inside. And using that one will further facilitate the development of this optical wireless communication, because as you know, like the main challenge in optical wireless communication is this blockage. So if you can have kind of a transparent RIS that can enhance further the extension, the coverage and the strength of the received optical signal, then that will definitely introduce a huge advancement in these technologies. And the most recent advancement in intelligent surfaces is to have like a really 360 coverage using this intelligent surface. The initial one was like all served users should be at the same direction. So the transmitter and the receiver should be at, for example, the front of this intelligent surface. But now you can have users at the back and at the front. You can have a reflected signal for the users in the front of the intelligent surface, and then you can as well transmit to the users at the back. So you will provide kind of 360 coverage at the city. It's not limited to one direction. This is really important for realizing the smart city application. And now in minutes, I will highlight more why we need digital twin for intelligent surfaces. And as I mentioned as well, the optical wireless communications, it's a promising technology for future wireless networks. It has high security level, high performance, given we have a line of sight, and it can serve many, let's say, low priority applications with like parking, let's say smart parking, advertisement, messaging. These are not critical applications. So that's not like for autonomous driving, although it has been proposed for vehicle to vehicle communication, but not like for more critical or risky situations, because any blockage in the line of sight will affect the performance of the received optical signal. Optical wireless communications are easy to deploy because we can use the current lighting infrastructure, any light emitting diodes implemented inside cars, in the streets, inside trains, airplanes, everywhere can be utilized, not only for lighting, but also for transmitting. And then non-terrestrial networks, where we have aerial nodes, as well as I will talk about satellite communications. So any non-terrestrial or not a ground node will be technology for enabling smart cities applications, because in many scenarios we have a blockage. In many scenarios we need to cover rural areas where we don't have any wireless communications. In many scenarios we need kind of on-demand communication that should be achieved like with a very low latency. In that case, we can send a UAV to cover a particular disaster area or rural area, and then to provide that high coverage. And in addition to that, if we can place an intelligent surface, that the one that I just discussed, at an aerial node, then we can have really a very extended or a large area covered with wireless connectivity. And we can, by tuning the parameters of the intelligent surfaces as well as the parameters of the aerial nodes or the UAV, like the elevation angle, the speed, all of these parameters can get an optimum coverage with optimum services or quality of service. Another one is integrated sensing and communication. Now with the pervasive sensing and the development of many sensing applications, the integrated sensing and communication paradigm has emerged as a way to provide better performance for both communication and for sensing. So not only they share the same resources or the same spectrum, but using sensing applications will realize better, for example, channel acquisition, and then it will enhance the communication performance. And the same for communication as it assessed in sensing, because the transmitted signal can be used for as well localization and therefore enhance the sensing performance. So this is a new technology that will be as well envisioned for smart city applications. Now,
hi, Doctor. Sorry, would you mind to wrap it up quickly? Yeah.
I've finished my time.
Yeah.
Okay, so just as a conclusion, why we need digital twin? Maybe Mikhail provided an idea what digital twin. It's kind of a virtual replica of a real environment, and why we need it. As you see, like we have a huge amount of technologies in order to serve a huge amount of users, and finding the optimum services or the optimum performance, the optimum resource allocation between all these technologies, and the need for the smart city can't be done at the physical layer. It will be very consuming. It will never reach the optimum value, and it can be risky to try different scenarios within like the real environment. So having or leveraging the digital twin in such scenarios where we can even generate more data over the cyber twin, acquire data or sense data from the physical environment, and then do kind of machine learning or AI frameworks to train the network to perform better resource allocation, better transmission, better coverage, tuning the risk parameters, tuning the UAV parameters, the communication and sensing integration. All these technologies can be really optimized by leveraging the digital twin in future wireless generations. And I guess that's it. Thank you.
Brilliant, Dr. Lina. Thank you so much. That was very helpful. Now move on to the next speaker. Let me introduce Dr. Huda Chihi from Tunisia, to present on the 5G network slicing. Over to you, Dr. Huda. Dr. Huda, are you there?
Yes, just 2 minutes, because I thought there is a speaker before me. No worry. So, hello everyone. Just a second to show my camera. Could you see me?
Yes.
Okay, no worry. Hello everyone. I start by thanking Professor Kanish for this opportunity to give me the chance to present my talk about 5G network slicing. I think I will go in depth about the subject because there is some introduction about 5G, which was covered by the previous speakers. I hope that you can see my slides.
Yes.
Is it visible? Okay.
Yes, it's good.
Just I will give you a brief introduction about myself. So I am a PhD in telecommunication, signal research at Innovcom Laboratory of Subcom Tunisia, and Tech Women Fellow, so hosted at Qualcomm, California.
Okay, would you
Chief
mind to
Engineering.
enlarge to a full slide?
Sorry?
What do you mean?
First,
Are you able to enlarge to a full screen?
full screen, yes, for sure. Just I will give you small introduction about myself. So, and I am a chief engineering at telecommunication operator. So as I told you, my talk of today will be about 5G network slicing. So let's go in depth about the principle or the concept of 5G network slicing. It is a revolution, and which is about in the way that is enabled slicing of the network into different networks using the same common infrastructure. So we don't have to define or to build for each slice or for each use case nodes, but we use the common infrastructure, the physical nodes, and through virtualization using specific technology that I will speak about later, we can virtualize or build other elements or slices where each slice corresponds to each use case. For example, for 5G, we speak about enhanced mobile broadband. For services about streaming, we have a unique slice isolated for a logical and another slice, which is about machine connectivities like smart cities, smart agriculture, another slice corresponding to vehicular communication, for example, or autonomous driving in general. So let's see an example. So we use, as I told you, we use a common physical infrastructure, common nodes of 5G network, and through virtualization, we obtain different P elements or slices. So, and each network slice is defined through a function layers. We find a resource layer corresponds to the required resource, which whether it is logical or physical. We find another layer about network slice instance. It is the logic building of network or network establishing, where we find the access, the core part, and the transport part, and another layer where we find the outcome or the services corresponding to each user equipment or in general service provisioning description. So all of these controller or orchestrator which controls the activity of each layers. And for which is the common, there is a common nodes which assigns for each user equipment a network slice. These nodes is called NSSF or network slice selection function, which works with other management function called CSMF, NSMF, and NSSMF to in the way that gives to each user required network slice. For example, let's start by the CSMF, Common Service Management Function. It is in charge of converting of the communication services to the corresponding network slice requirement, and by which and transfer the requirement network slice to other management function called network slice management function. It is in charge of or stands for network slice instance orchestration and management, which by its side transfers the requirement to another nodes called or management function called network slice subnet management function. It is in charge of orchestration and management of network slice subnet instances. Here we have the three functions to enable end-to-end network slicing. But the identification of network slicing is enabled like PLMN. We have PLMN ID. We speak for if we have 2G or 3G, we speak about PLMN ID. For network slice, we speak about identification too. If the identification of each slice is done by single network slice selection function, if we have assignment of for user equipment a single identification of its own core or run or transfer parts. If we have user equipment assigned to different slices, we speak about single network slice selection function, and which the identification network slice assisting information is composed by, like I told you, it is like PLMN ID. It is the identification of each slice is composed by slice service to identify which is service, if it is EMBB, URLC, IoT, or vehicle to everything communication. And we have slice differentiator if we have, for example, user equipment, which is assigned to different things. If we talk about slicing corresponding to massive machine type communication, it is a kind of differentiating between the slicing inside the same slice. So what are the benefits of network slicing? So, yes, I forget to tell you to speak about the enabling technology for network slicing. We told that network slicing is based in virtualization. So this virtualization is enabled by software-defined network, which is in general it is built in data centers because it's like routers. It is plays the role of assimilating and the traffic between the slices, and NFV or network function virtualization enabling virtualization of the different nodes inside the network, and it's normal to be built in operator or service provider. So by this way, we say that network slicing provides safe in terms of CapEx and OpEx, but there is some lack towards security and building business models. So thank you so much.
Well, that was very quick, Dr. Huda. I appreciate that. So
to save time.
yeah, no, I'm
Is it
searching for the
clear?
last speaker, Raghuram. Suddenly he's disappearing. So I'm trying to get in touch. I'm not sure whether he got disconnected or what. Maybe while waiting for him to talk, maybe we'll have some quick Q&A in between. One of the areas that I wanted to discuss was maybe I have something to ask from Charu when it comes to the 5G private network. I wanted to hear your thoughts as well, just to see like, just 1 second, yeah, okay. Okay, so I just wanted to know, let me share you what I gather from the industry based on what's going on for some of these guys. Yes, private network is something really challenging when it comes to deployment, because first, the government needs to be very open. The government needs to gain more support from the industry, and the devices can be another issue as well. So, as we know, 28 gigahertz can be a good to be introduced in the private network, but unfortunately, the issue is because of a short coverage, right? Because it's a short distance coverage and everything. So, do you devices is a difficult part, but when it comes to the other part, like between the range of 3 or 2 point something to 3.5. There's more devices available. But on top of that, in terms of the connectors and the sensors, do you think it's commercially it's already available right now that is can be launched quickly, or is it something that we got to wait?
See, it's not that there are no device availability at all. There is some. It is just that the main application, the device availability when it comes to the typical industrial scenario, the critical, mission critical application or those industrial IoT application that require latency or the bandwidth or that need to function on a very high speed. So those are the type of devices that still need to be developed. And moreover, it's not just the availability of devices, it is also about the developing the entire ecosystem. So why do we see more and more enterprises opting for 4G network, 4G private network deployment, or why the number of 4G private network deployments are higher than 5G? Device ecosystem also plays an important role here. We have a complete setup of ecosystem available with us when it comes to LTE. There are right price points available for devices and even for deploying the solution. So when it comes to 5G, device availability is a challenge, as well as it also goes to the price point level, because the more number of devices that you plan to deploy in your industrial scenario, for example, when it comes to public sector cases, or you have to deploy a private networks in mining scenario. So these are the network deployments that will require a good number of devices compared to deployment in a limited area, for example, in some office space area. So in such scenarios, price points also play an important factor, because with 4G, you can play around with the prices, right? Price points are available, multiple options are available, wherein when it comes to 5G scenario, these things do impact the uptake of 5G networks.
Thank you, Charu. So lastly, I would like to introduce Raghuram Mehta from London, UK to present on the 5G Edge Cloud.
Yeah, hi Kanesh, can you see me?
Yes.
Yeah, hi Kanesh, thanks for inviting me. It's a great to be here along with the experts. So I'm going to give a short session around the different capabilities that are required from Edge applications point of view. So before that, my name is Raghuram Mehta. I'm the Chief Enterprise Architect working in one of the business group within Tata Consultancy Services. So let me share my screen. Can you see my screen?
Yes.
Yeah. So as agenda, so I'm going to cover mainly 4 broad topics here. So at first, whenever we say edge applications, there is a lot of context and different, it means different for different people. So I'm going to talk about the context of edge, and then when we talk about this edge and cloud continuum, so there are various characteristics that we need to consider in terms of the applications point of view. And then I will talk about what is exactly the continuum from edge to cloud and vice versa. And then the what kind of 5G capabilities that are being brought into the gamut, so which will accelerate these edge applications and edge computing that is required. So if we see from edge computing point of view, there are different edges that we generally hear across the industries. So for example, there are device or user edges. I'm also calling it as an endpoint computing. And then we have got these consumer edge computing, which are more like public services or citizen services edge. And then we have network edge, which is more telco specific. It is also called a service provider edge or MEC, multi-access edge computing. And then we have mobile edge computing, which is more relevant for the smart transport or smart logistics applications. And we have these enterprise edge computing. So this is more like where we talk about private networks, enterprise private networks, enterprise computing with or on-premise computing. And then we have cloud edge computing. So where we have these cloud CDNs or regional local edge solutions that are provided by hyperscalers. So these are all the different type of edge categories that we have. So it is always important to understand the context when we speak about this edge to cloud continuum. So here there are different characteristics of edge applications. So for example, there are some applications which are heavy compute process intensive, like analytics or intelligent automation, robotic process automation, where a lot of AI and ML inferences will happen at the edge. So they will be more compute intensive. And there are applications which are throughput and integration intensive. So these are like very much data intensive applications where it requires a lot of data processing at the edge and as well as integration among the edge devices as well as with the gateways. And then we have applications which are latency intensive, where we have got a lot of these healthcare applications or emergency service applications, even the autonomous vehicles that are coming up nowadays, and AR/VR applications. All these things required very low latency applications ranging from 10 milliseconds to 30 milliseconds and 50 milliseconds. And then we have content intensive applications. These are like video streaming or data streaming, or as well as voice traffic or web traffic. So which we generally see with the consumer applications, with mobile based applications or all those applications where it is heavy content intensive, it will be more predominant in the public consumer services. And then we have security intensive. There are certain applications where the security or data sovereignty, data protection is utmost important while processing the data at the edge devices. So all these things are very high niche services, or for example, kind of military applications or even the aerospace applications, all those things which require some kind of security measures and then data protection requirement is there. And then we have certain applications which are heavy uplinking required from the edge devices, such as these predictive analytics or central monitoring applications, where you will be sending the data to cloud or central system, central processing. So where you will be monitoring the systems, where you will be monitoring the applications, and then you will be taking a predictive or proactive action based on the conditions. And then there are certain applications which are downlink intensive, so which are predominantly like mobile applications or video streaming applications. All these are very heavy downlink intensive rather than uplink intensive. So we need to understand all these different application characteristics when it comes to edge to cloud continuum. So now we have, when it comes to this edge to cloud continuum, we have got a lot of intermittent parts to play, like their components and their networks, their different players and ecosystem is involved when it comes to edge to cloud continuum. So it is like a continuous flow of data, continuous availability of connectivity, and continuous flow of the processes and workflows. So like as you see, there are a lot of these independent entities involved, right from the endpoint devices. There could be machines in the assembly lines or manufacturing factories. There could be things in the smart home, or there could be systems or equipment. And then we have these offsite edge controllers or gateways, which will be more playing a kind of a control and integration function among these edge devices. And then we have these on-premise local edges, which is private MEC we call generally. And then we have network edges where 5G is enabling these kind of RAN-based stations co-locating MEC. Network edges, transport aggregation, central edge, so which is like cloud edge. So, and then we have the cloud or internet connectivity. So there are different requirements that are required to maintain this continuum efficiently, like these kind of latency, throughput, flexibility, reliability, and then security aspects, and most importantly, dynamic control and federations, and the cost effective and efficiency. And then there are various partners and ecosystem that needs to be engaged here. Not one or a single entity can fulfill this kind of end-to-end edge application solution. So it is entirely an ecosystem play. Not just telcos can do it, or not SIs can do it, or not just hyperscalers can do it. So it is definitely a ecosystem where everyone have to play their part. So, like for example, infrastructure as a service. So we need to have these kind of service-oriented infrastructure management across the devices. So where you can provide the infrastructure using the cloud native infrastructure services and as well as other capabilities. And then we have connectivity as a service. So this is very important. This is where 5G will play a critical role. So because we can see a lot of different connectivity requirements across the spectrum, as you see here. So we have varying from 5G to fixed wireless access, LoRaWAN, and BIoT. There are a lot of other connectivity solutions that are adapted near the edge or at the edge devices. And then we have the 5G connectivity acceleration. That's what I'm calling it as. So where we use this MEC, multi-access edge computing, to accelerate this connectivity demand and then orchestrate the connectivity requirement for all these different edge devices and different edge applications. And then we have this fiber backhaul, which will be connecting to the core data centers and as well as cloud and net. So this is where telcos will play a critical role. So in order to enable this connectivity as a service or network as a service, using all these different next generation network capabilities, so that all these edge applications and can uh, uh, perform as required in terms of performance or latency, all these requirements. And then we have the digital platforms and services. This is also a place where telcos can play a part apart from the connectivity services. So we have these digital platforms and services and as well as system integration providers, where recently a lot of new players are coming into the market who are providing these cross platforms, cross industry platforms and verticalized services. So where which will be like platform as a service or SaaS based model. And as well as you need to have a specific system integration play as well, which will satisfy these kind of application integrations and as well as cross system integrations. And then we need to have this kind of single pane of glass, like you have these multiple parties, multiple systems and multiple capabilities which are played by different entities in this overall end-to-end ecosystem. So you need to have that kind of a single pane of glass, whether it is for observability, whether it is for control, and as well as orchestrating different services dynamically and as well as based on the real-time conditions. So whether it is at the network control plane layer or whether it is at the data plane layer. So across the end-to-end spectrum, you need to have different control functions and management functions and as well as, excuse me, so orchestration functions need to be performed. So and then you have these edge applications, whether they are B2C, B2B, or even the developers. So where they use these platforms and services provided by different parties and different entities within this end-to-end picture, they can leverage these services so that those edge applications can be built for the different requirements and needs. So now coming to the 5G enablement. So how 5G is enabling these edge continuum to cloud. So for example, edge to cloud integration using these 5G NSA or 5G core LTC EPC site or 5G core site function. So we can leverage this service-based network architecture to manage this control plane and as well as user plane functions very effectively, so that we can satisfy the low latency applications and as well as the reliability conditions. All those things can be easily managed and satisfied by the telcos. And then we have these dynamic optimization and SLAs are very important here, especially when we see cloud gaming or whether we see any industrial IoT applications or any smart ports or smart city applications, all where we have these low latency requirements or throughput requirements. So those kind of SLAs have to be met absolutely. Even for example, autonomous vehicles. So you need to maintain a dynamic conditions. You need to satisfy the dynamic conditions as well, where the same edge application may require different type of SLAs at different point in time based on the conditions and the environment. So you need to optimize the networks, and also you need to prioritize and using network slicing function, for example, or spectrum sharing. So we need to make sure the 5G and MEC will enable that kind of optimization in the network connectivity. And then the 5G is also bringing up these kind of autonomous networks. So where we will, where the telcos are making the next generation networks, where everything can be autonomously and automatically done, whether it is network operations or policy updates or the performance or analysis. All these things need to be done by using autonomous networks. Of course, different telcos are at different levels of autonomous networks currently. And then we need to have these kind of different endpoints. So like as you see, there are the same network, the same network capabilities have to kind of attribute to different edge endpoint applications. There are, and they will be dynamic and they will have different characteristics as well. So these kind of different access points have to be managed effectively. And then the large number, there could be any scale that need to be met as per the applications. And then we have
due to time factor, would you mind to quickly wrap it up?
Yeah, I'm done almost. So,
Okay.
And then we have these multi-domain orchestration services. So these are all very much required in terms of, because as you have seen in the previous slide, there are different entities and different networks involved. So these kind of multi-domain orchestration and services is absolutely required. And that can be managed by these 5G and MEC capabilities. So yeah, I think that's all pretty much. It's a very short perspective that I wanted to give on the capabilities that are required for edge to cloud continuum. So thank you for this opportunity, Kanish. Thanks all.
Brilliant, Raghu. Very precisely explained. Thank you so much. I appreciate that. Let's have a
Thank
quick 10 minutes Q&A. Thank you, Mikhail, to join us back because I have something to clarify from you. Maybe I can start with something. I mean, any other speakers, please feel free if you have any questions. Maybe I will start with Mikhail first. You know, when it comes to the 3D digital twins, I think that was fantastic. I just want to know how this scanning is being done. Are you able to share, you know, like big, like Skoda that you were mentioning, how precise the scanning is done and what kind of devices that you use for the scanning?
Yeah, so there are multiple options how to get the 3D model, and it depends on the use case you have. So in our case, it's not that much about the precise or super precise passportization. So when companies or organizations in general need to have, so they have the site already, they have maybe 2D drawing somewhere on the paper because it's 50 years old building or even older. So then a LiDAR scan and created BIM model is the right option. If you build a new building, it's always good to have the BIM model immediately. But most of the companies are somewhere in between, so they have 2D layout either in PDF or in the XF or something like that. So they come to us and say, guys, we would like to make it live. How to proceed? And then it depends again on the use case. So if it's the logistics or the production, or they want to see just roughly how the site looks like, it doesn't need to be super precise. If they need it for passportization, it has to be, because they need to measure every single cable, every single thing they need to achieve. So it depends mainly on the use case. But it is important to understand that companies or organizations need these detailed plans mainly in the construction phase, or if they do some relayouts or something like that. For the operations, they don't need that precise model. So we are not competing with solutions from Autodesk or something like that. No. We don't want to be in the construction phase of the facility, but in the operations.
Thank you, Mika. Thank you. Thank you so much. The other thing I wanted to know was that Dr. Lina, you were mentioning about the RIS. That is really fascinating. Do you know, I mean, roughly when this will be commercialized?
Actually, I have no idea as it's still in the research, but they have manufactured like our initial deployment for some intelligence services, and it demonstrated really strong performance in terms, not the transparent ones, although they are still, they have already developed these ones, but for the conventional ones, they demonstrated a strong performance in terms of extending the coverage.
Right. So we have roughly maybe another couple of years to go, or
I believe so, yes.
right, right. Thank you, Doctor.
And can I ask a question for Mikael as well in terms of the digital twin? Um,
Sure.
I just want to, if the services that you are providing, to what extent it is interactive in terms of the interactions between the physical and the cyber environments? Is there any feedback from the cyber twin to the physical twin, or it is just sensing from the physical and monitoring at the cyber twin?
Yeah, right now it's in one direction, and it is actually not a technical reason, because if we call this kind of service or that kind of service, there is no difference from our perspective. But in most cases, we don't need to take action if something happened. People mainly need to get a notification, aha, something happened, I get notified, I want to see where it happened. Okay, let's go there, let's do it. Because you have so many information systems in all these mainly plants, because we are very strong in manufacturing business. And if you have 38 information systems in one plant, now to do every single integration, it doesn't make that much sense. So,
and in terms of
reason, it's a pure cost and benefit math.
Right. And in terms of accuracy, in terms of latency and time sensitivity, is it like a really live sync between the physical and the cyber twins? Or there is a time lag, or?
Yeah, there is, of course, some lag, few seconds. It depends on the connectivity on all sides, because you have the connectivity on site, you have something between you and the cloud, then your connectivity to the cloud, because it doesn't need to be on site. So depends on this stuff. But look, most of the companies are living with the paper. In better cases, Excel or Google Sheets or something like that. So they discovered document sharing already. Great. So these super no latency topics, it's not that important for most of them, because now they are blind, and if you provide them with a picture, they are super happy. And if the information 5 or 10 seconds old, nobody cares.
Right. But it might be matter more like in future for more critical applications that requires like very latency requirements. I believe it will be really a challenge.
Exactly, it will be, but the organizations are not ready for much simpler and easier tasks, and not to perform a surgery via 5G.
Right. Okay? Yeah, right.
But it will be a pleasure.
Yeah, Mikal, I have a question. So this is Raghu. So your presentation was very nice. It's a real demonstration. And one question I have is, as part of your plant operational visualization, and as well as getting the data from the plant, so what are all the type of networks you are using? I'm sure you will be using multiple types of networks within the plant, and then from the plant to the central offices. So can you just touch upon what are all the type of networks and connectivity solutions that you have deployed for your solution?
Yeah, it depends on the technology, because, for example, for desk presence, there is a LoRa-based technology, so it sends the sensory data from the sensor via LoRa to the server. When we talk about location-based services, So if you have something what has the infrastructure on the roof or somewhere, it has power over Ethernet, usually cabling, and again, it sends the data somehow to the internet. If you are using interpositioning technologies and you are locating the phone or the tablet or this kind of device, the device has some kind of connectivity, and again, it sends the data. Plus, we have more and more integrations with already existing information systems. So we don't talk about IoT data or anything like that. No, they have their warehouse management system and production system and quality and all the stuff. And they need to get the data under one roof. And it's for them not important from the perspective, I want to manage something. No, I just want to see online, on time, this parameter with this parameter with this parameter from 3 information systems. There is a correlation or not, just I look at that and that's enough. In the future, of course, there will be all the AI stuff saying the pattern is now arriving. Please be careful because last 2 weeks ago there happened something, but the technology, the customers, the information systems, the infrastructure is not that far yet. So in theory, yes, but in reality, no.
Okay, yeah, thanks for explaining.
Sure, pleasure.
Anyone have any questions?
I have a question on 5G network slicing. I think probably Dr. Huda can help me out.
Yes, I am here.
Okay, so I just curious to know what is your outlook for 5G network slicing? For instance, if I talk about things like 5G standalone deployments, we still
Yes.
have seen only a handful of operators deploying 5G standalone networks. Mainly it's on NSA. The industry is still warming up to this topic. So how do you view network slicing in such scenario? Do you see operators picking it up in next 1 to 2 years, or you think it will still take time for the industry to warm up to network slicing and use cases to develop?
Yes, thank you so much for your question. In fact, network slicing in specific countries is deployed for standalone. In particular, I have seen an article on an operator in Germany is Vodafone, who implemented network slicing for standalone. But for further years, I think that will be deployed in many countries, but it depends in adoption of standalone architecture. That's okay?
All right. So is it fair to say, I mean, because again, I'll say that there are not many standalone deployments.
Yeah, exactly.
Yeah, and why is it that the industry players are still hesitant to go for standalone deployment, apart from those reasons like it is more expensive, of course, as compared to NSA? Any other particular reasons that you see?
You mean for the adoption or the implementation of network slicing into standalone?
Yes, in view of standalone.
It's related to the use case, and because for standalone, it gives us more use cases related to reliability, broadband. It's more advantages if we go for a non-standalone, because we have to go to APC and we have more latency, and because if a use case or the advantages of network or the adoption of network slicing is to gain in terms of bandwidth, of latency, especially for gaming, streaming. So it's much benefit to use standalone than non-standalone. For this, there is a particular operator adopt the architecture of network slicing into standalone.
I would like to add something here because I noticed that this is a very favorite question as well. And I think most of the mobile operators or the most reliable or cash rich are willing to go directly to a standalone, right? Because
Yeah,
the price is at the end of the day, it's all about cost. If the price is like 4 or 5 times higher than the 4G
yeah,
equivalents, and like countries like you can see South Korea Telecom or Korea Telecom from South Korea, they are daring, they are willing to, they have invested like what 10 billion couple of years ago. No any other operators are willing to take that kind of daring to invest such a huge money to go from a scratch green standalone. Perhaps from US, Vodafone from UK. Some of these top
Germany.
guys they are willing to take. But other than other operators, they prefer let's wait and see because they can't able to see the consumers are ready to embrace the 5G applications, and that's why they say let's start slow with NSA. We'll use whatever that
Yeah,
the existing infra, and then slowly once the consumers are growing, and then we can start to move towards to the standalone. So it's a watching game, right? And whether the consumers are really ready to embrace the application. So yeah, let's see how it goes.
Yeah, Ganesh, I think
yes,
I want to add one more point on that. So, for example, in India, if we see Airtel is launching 5G services using non-standalone, whereas Jio wants to invest in standalone networks because of the future roadmap they have got in terms of the applications and in terms of the different services they want to provide. So, like it all depends on the how much investment that the telcos can do and what is the roadmap. So, accordingly, the telcos are investing either non-standalone or standalone networks. So that's the kind of difference we can see across the world. So
So at the end of the day, it's all about cost here.
yeah, exactly. So
Yeah.
end of the day, they are not going to increase the prices, and obviously consumers are not going to take up if they increase the price. So it's all about how much ARPU that telcos can drive, and at the same time, what are all the add-on services that they can make a business on. So not just on the connectivity or mobile services.
One more thing here to add regarding this, also for non-standalone right now, the all vendors are having specific features that simulated. We can say that this is the initial stage of network slicing. For example, at Ericsson, they are using radio resource partitioning. Just they can split the bandwidths to 2 bandwidths or 3 bandwidths, it depends. And each part of the bandwidth can be assigned for a different KCIs. For example, for the FWA deployment here in UAE in Do, so they are split the bandwidths to 2 parts. One is specifically fixed for the FWA users, and the remaining bandwidths are used by the mobile broadband. Maybe this also, the new features also can delay the deployment of standalone.
You mean this can be applied on a non-standalone?
Yes.
Oh, all right.
Even starting from 4G as well for the radio resource partitioning and for 5G.
It's called as what? Resource partitioning, right?
Yes, radio resource partitioning.
Okay. And they can enjoy the full 5G
all over the UAE.
application, is it?
Sorry?
They can enjoy that 5G application.
Yes.
All right.
Yeah, for example, here they do the FWA 5G, and for the enterprise, small companies, the enterprise with a guaranteed quality of service, and the remaining band used by the normal mobile broadband users.
Awesome.
Can I ask a question? This is my last one. So have anyone seen adoption of these connectivity orchestration platforms and solutions, especially like I'm talking about my topic around the edge to cloud continuum. So I can see there are a lot of fragmentation as well as different parties involved. So have anyone seen this kind of orchestration adoption, or anyone already working on these kind of solutions in practice? And as well as, are you seeing any customers, whether enterprises or consumer-based applications? So are you seeing any customers asking for those kind of requirements and solutions? Anyone, if you are aware of those kind of mainly the end-to-end orchestration. So whether it is connectivity or the platform services or digital solutions. So I think I'm sure there is a definite need to have these kind of end-to-end orchestration solutions. Otherwise, it will be very difficult when there are a lot of parties involved, and customers cannot deal with these different parties to deal a specific problem. So we need to have an integrated ecosystem play here. So I just want to understand if anyone have seen such requirements from the customers, specifically like enterprise customers, whether whoever is using private networks or the manufacturing industries or smart factories, anyone. So have anyone seen such requirements asked by the customers and they're looking for those solutions?
Maybe I just want to have some thoughts here. It's my 2 cents thoughts. Yeah, this is what I observed for the last 1 year. I don't really see mobile network operators really fully ready for a full orchestration yet.
Yeah. Agreed.
Maybe one or two, top big guys, maybe they are willing to indulge. But what I realized from the age perspective, I see the hyperscalers are playing a bigger role here, where they already have this boxes ready, and it's so straightforward, so easy. The users can able to just apply a subscription monthly basis, cloud. It's available everything, right? It's just click and drop, something like that. So straightforward, right? And I don't really see that is really happening as an offering by the mobile operators. This is what I have observed. And I think hyperscaler taking a bigger role because they already have those cloud storage facilities long time earlier, right, than the mobile operators. So they are coming out with the differentiated services, and that's how they're coming up with edge and also private network combination with edge as well. So I don't know, maybe I haven't seen them offering an orchestration yet at this point of time, because I think mobile operators are having a upper end to do that, such kind of full end-to-end orchestration. That's my thoughts.
I think I see more of a system integration play, because if I am an enterprise, like either a smart factory or a manufacturing assembly line environment, I might, as a customer, I always willing to go to one party to provide the solution and manage it, rather than going to 10 parties within the ecosystem. So I think that kind of system integration play will become very much prominent and becomes a need of the hour going forward, as I see, and as well as telcos transforming themselves like a digital service providers rather than just a connectivity provider. So I think those things, I'm sure we will see more and more of those solutions and requirements, in my view.
I believe the new players like Rakuten and the Dish network from US, because they can do it, they are fully green. They can come out with a new fully orchestrated, fully automated.
Correct. Yeah.
Right, because everything is cheap. They are trying to test it out with Open RAN. So it's much more easier. The cloud native, they are trying to test it out fully. So I think that's a possibility. So if this thing is really successful, I think you can see more players would want to do that. But the traditional guys, I don't think so. They are ready to not to say mess up their infra, but they're taking an extra alert. Maybe they are not ready yet to do a full orchestration.
I think there is a lot to do. I think that's why they want to first start transform their networks to make it more autonomous and autonomy oriented. So I think that's the first thing mobile operators have to do. I think that may be the case. Maybe we'll see in future more and more players entering into this market, and Open RAN and all these things will definitely enable that. So more players come into the industry, and a lot of innovation will happen, certainly.
Absolutely. All right, guys. I think I don't want to take much longer of your time. Thank you so much. I really appreciate all of you.
Thank
It was a
you.
fantastic presentation. I think it's one of the best presentations so far. And I really appreciate for your time. This whole presentation video will be uploaded on YouTube in a couple of hours. And thank you so much for NTU Singapore for hosting us, the Zoom platform. And for the audience, please do take a couple of seconds to click the subscribe button on our YouTube channel. Speakers, please support us to click our subscribe channel as well. And I really appreciate till we meet again. Have a nice day and have a fantastic week. Thank you so much, guys. I appreciate it.
Thank you.
Thank you all.
guys.
It
Thank
was
you all.
nice meeting you all.
Thanks, everyone.
Bye.
Bye.
Thank you.
Bye.
Bye.